Now in this video, I'm going to show you on Form 4 Physics, Chapter 2, Part 6, Inclined Plane. Now, just before I get started with this chapter, what I'm going to show you here would be a mechanism at which from the floor, this is the ground I have. If I were to have a plane, you're given a plane, this plane is actually a piece of wood maybe. Okay, and then I will have a stand of holder or a jack. Okay, you are able to jack it up and down accordingly. Okay, now what happened when this jack go up or down? I'm going to put a piece of maybe eraser or a piece of wood on this piece of plastic. Now what happened, I want you to realize, I need to first let you know that this thing will move, and I need to bring you a concept of friction. Okay, I will talk about frictional force in my next video, but here I just want to give you the idea that this object will glide down. Okay, now when the object is horizontal, nothing will move. As when you start to glide up, eventually this object would glide down, move downwards at certain angle, right? When it's here, maybe it's not moving. You can try this experiment yourself. You need to get a solid wood or anything, solid flat surface, put an object onto it, and you gently lift it upwards. Gently meaning slowly. Lift it upwards slowly. Eventually this object will glide down. You need to stop the moment before the angle you stops. Okay, then they will help you to find out the frictional force. But we are not into that yet. I will talk about that, how to get the coefficient of friction between two objects in my next video. But for here, what you need to do is you need to at least first agree with me. At least we're on the same page of the book. You need to agree with me that this object will glide down at certain angle of inclination. Okay, at certain angle, when it is going up, certain angle, this object will start to move. Okay, so there are two types of friction. I'm going to start a little bit. The one that stops it from going up, the initial one, is called the static friction. When it's static, it's not moving, meaning when it starts to move, then they will call it as universal or dynamic friction. Okay, so when it is stationary, dynamic. Okay, dynamic friction. It's when the object moves. When the object moves. In order to make an object to move, you need to have frictional force. That kind of friction is dynamic frictional. Dynamic frictional force. The one that will help this object before staying in equilibrium, before it starts to move, that is called the static frictional force. Static frictional force. Frictional force. When the object impeding, impeding is another word. Impeding force. Before object move. Before object moves. Okay, that kind of frictional force is called static frictional force. When objects start to move, then that's dynamic frictional force. Let's not talk about frictional force. Here we'll talk about inclined plane. Okay. Here, at this instance, I'm talking about what happened just right before. Okay, just right before, we are talking about static frictional force here actually. So just right before I start to move. Just before the object glide down. Okay, just before that. Okay, the moment just before that, maybe I'm going to redraw that in a bigger diagram. I need to spend some time on it. Instead of drawing that diagram, I'm going to draw a triangle just before that. I mean, this angle is relatively bigger. Okay, just before that, static. Okay, height, and yes, again is triparticulars. I have the object here. Maybe I put in the center, slightly bigger, so that you can really see it. Okay, so what happened is the interface between this green and blue, if you put it into a microscope, the surface would be like a rough surface. Okay, and then the object will be not smooth, also it's also rough. That's why the object is not moving. Okay, so this kind of frictional force we're talking about. Okay, so this is just right before that to stop it. This is the static frictional force. Okay, here it's actually enlarged from here. Enlarge it. Okay, so what happened? You need to solve it. Okay, first you need to learn to draw, how to sketch a free body diagram. The law to get a free body diagram is you label the force that act onto it. Okay, first you need to label what are the force act onto the object. What the force act to it? First of all, easiest one would be gravity, right? So the gravity will act on it, and therefore you get weight. Okay, so this is where you point towards the Earth, mg, mass of this object. G is the acceleration of the Earth. That's where you get your weight. Okay, and this weight is not a constant because it would change. The gravitational pull in the moon is 1/6 less. It's only 1/6 of the Earth. So the weight of this object in the moon would be lower as compared to when it is in the Earth. So the value for this gravity, as in from 5 SPM, you may regard as 10 meter per second. As only limited to only SPM, you may use 10. Otherwise, a more accurate answer would be 9.81. This value is accurate as long as this object is below, if the object is located below the Mount Everest. Okay, Mount Everest mountain. Okay, it's about 8 kilometers. As long as it's 8 kilometers below, I mean within the Earth, as long as this object is located below, okay, the Mount Everest, then the gravitational acceleration is accurate, yeah, to be 9.81. But for Form 5 purpose, you may use 10. Okay, doesn't need to be for SPM purpose. You may use this value. Okay, doesn't need to get obsessed with this 9.81. That doesn't need to be so particular about the accuracy at the moment, because 10 will do just great. Okay, for SPM, when you're studying SPM, use this value. Once you're in your pre-U, your A level, then yeah, you need to use 9.81. Okay, so come back to here. First label the first force is the force act onto it is the weight. This is where it perceives gravity. Then next would be the normal force. Normal force is always away from the surface, the interface, so would be always the center of gravity going upwards. This is where the normal force, or I don't want to confuse you with Newton, so I will use R as force and reaction force. R, which is the normal force. Then there are friction. Okay, I need to erase this. Okay, it's blocking my wheel. Okay, so here, this object, just before I start to glide down, there is a frictional force. So this frictional force, I want to label it. It's supposed to be between here and here, but I don't want to separate from the free body diagram, so I label it here. Okay, this is where my frictional force, maybe Fr, subscript R. Then, okay, this is my box, and this is the inclined plane. Okay. Then those are the common value for force that you know. Then from my previous video, you learn about resolution of force. So now in resolution of force, what you actually learn is you need to resolve it. Okay, what is resolution of force? First, what you need to resolve. Where is the force that you need to resolve? It's actually here. This is where the resolution of force. Respect to what? Now, because since that this is where the horizontal now, this is where your support, this is where your object is being supported. It's always the case you make this as your reference instead of the one here. Okay, this one here, the earth, enable you to find out where's the gravity, act onto it downwards. Okay, but when you look for reference, so this is your reference, this is the horizontal, therefore this line is your x-axis, and tangent to it, this is the vertical axis. Now, in this triangular, this is one rectangular triangle, so this angle here is also theta as equivalent value. Okay, I'm not sure you can see it, because here that's one triangle. Okay, this is one triangle, and then this is another triangle, right angle triangle. So the value here is equals to this value. They are supposed to be the same. Okay, this value will be same as with this value in terms of angle value. If it's 30, then it equals 30. Okay, you might need to pause this video for a while and then to look at the logic of it, because there are two triangles. So this is right angle triangle, this is also right angle triangle, so this value of angle is equal to this angle value. Okay, then if you manage to resolve it, then there are two. The first one, that would be the one going downwards. You need to find out what is this magnitude, because this is going downwards, so here downwards. Okay, because you need to drop perpendicular line, right? You need to drop perpendicular line to it. So this is first one, that will be my mg cos theta s. Right? If you get this value, then this value, the front is also the same as with the one over here. They are okay, right? You can see this in reference to with the x and y axis, horizontal and vertical axis, and it's now in inclined plane. That's why you need to drop perpendicular line 1, 2 from this mg. So here, this value would be equals to mg sine theta. Correct? They are parallelogram that I mentioned in my previous video. You need to pause this video, really, you need to pause it and have a look at it. Learn how to resolve this. If you manage to resolve this, congratulations, this is how you need to do, and this is how you need to solve questions related to inclined plane. If you manage to solve it, congratulations. This is all about it. This is what you need actually for inclined plane. Okay, then depending on what question they ask you, if this object going down at constant velocity, well, you will learn it in from my previous video actually. If it's moving at constant velocity, then the acceleration will be 0 because it's dv dt, therefore it's 0. You need to refer to my chapter 2, part 2, analyzing motion graph. Perhaps in that video I'll show you. So what you will normally see is that when this object is going down the hill at constant velocity, for the case 1 maybe, we'll talk about constant velocity. What happened is the acceleration is 0 of the object. Acceleration A is 0. Now you may ask why and how. Based on what we have learned, acceleration is actually rate change of velocity, right? If it were to be constant velocity, says if v is, let's say, it doesn't change with time, it's a constant number, let's say only 6 meters per second. So if we were to differentiate, in order to A, differentiate dv dt, if you were to differentiate a constant number, you learn from 4 maths, you may look through my video, from 4 differentiation. If you want a constant, you want to differentiate a constant, what happens? You get 0. There's no change. Or perhaps you may refer to from 4 physics, chapter 2, part 2. This in terms of mathematics, 0. You want to change, there's no change in velocity, that's why constant velocity you get acceleration is 0. So in the event that you get acceleration is 0, based on this inclined plane, here, when this object going down the hill at constant velocity, what happened is the mg sine theta. What's mg sine theta? Here. This mg sine theta, this mg sine theta is equals to frictional force. Or, put it the other way, if I were to define positive by going downwards, going down in positive, yes. So what I would write would be my mg sine theta as, this is a value, there are value here, I'm here just give you some unknown, subtract frictional force. Why is it subtract? Because frictional force going the other position, in a direction where I define positive going downwards. I define positive going downwards, that's why this is positive, and this is negative because frictional force act opposite direction. When it's moving at constant velocity, therefore the overall equation is equals to 0. Why is it 0? Because ma, force is, this is a force quantity, this is also a force quantity, this is force is equal to ma. Right? Newton law, ma. So when acceleration is equal to 0, so the overall force overall is equal to 0 overall. Okay, this is equals to overall, and therefore you may want to say, oh, okay, my mg sine theta, you need to get use of this unknown. The earlier you get used to those unknown, the easier your life would be. Okay? That's how you get to know frictional force. Right? So, this is how you come about to do here. Okay? Left and right should be the same. The same is true. Normal force is equivalent to mg cos theta. That's why this object doesn't go up or down. Doesn't go fly up to the sky. Yeah? But is about to glide down. So, case 2, what happened when it does have acceleration? Case number 2, acceleration. A now is no longer equals to 0. What happened when it's no longer 0? It means the object glide down with an acceleration. So with acceleration, it doesn't worry about velocity anymore. If you there were acceleration, then again, same. I define positive, going down. Same equation, mg sine theta as subtract equals to ma. This is where you need to look for, what's the acceleration? If you're given the angle and given the, you were able to find out what is frictional force, actually. Then you were able to find what's, normally they will tell you, the frictional force is how many Newton, what's the mass, angle, you were able to find it. Then you just solve this, divide by m, then you get your A. Then you know what's your acceleration. Okay? I hope you take note of this, because now the acceleration is no longer 0. They will give you a value, or they will ask you to look for, to find what's that value. Okay, based on this diagram. That's why free body diagram is important. The rule, the thumbs up rule would be, you need to label the force act onto it. The force act onto it. The force act onto it. The object. Right? Okay? I think I doesn't want to go deep down. That's basically what you need to know. Maybe they ask you to look for some other things. Well, I don't know what they are looking for. Or maybe I'll give you an example. You may stop this video and try those questions. Look for any questions. Eight to 10 questions about inclined plane and a sketching free body diagram. Now, okay, now given a scenario, right angle triangle. Now the angle is 30 degrees. They will give you a standard angle most of the time. An object is at rest. You need to find out what is the force. You want to prevent this object from gliding down. What is the minimum force that you need to apply, pushing it? On this object when the surface here is smooth, meaning there's no friction. The weight, they let you know, the object is 800 grams, or they let you know, oh, okay, it weighs about 8 Newton. They will find out what is the force required reference to the ground. Okay, it looks so hard. It seems you will not be able to solve it, but believe me or not, if you manage to solve it into first find out where's the axis. If this is where the ground going down 8 Newton, so what you need is actually you need to find out this here and here, the x and y axis. If you manage to resolve x and y axis, then things will be so much easier now, because okay, need to redraw this in free body diagram, maybe a dot. Okay, a dot, big dot, going down. It's where my mg is, 8 Newton. Okay, then up and down should be the same. I doesn't use the same color. Okay, here, drop perpendicular line. Okay, this is the x and y axis, 90 degree. So the angle here would be 30 degree. So therefore, one here is mg cos theta, cos 30, easier for you. And now there is an extra force. You need to find out what is the value of this force. Now, the zigzag rule, this is the 30 degree also. I mean, this is the horizon, 1, 2, I mean, this is 30 degree, right? So, I think I resolved it for you. In order to prevent sliding, what's the magnitude of force? So here, you need to find out what is this magnitude. So therefore, you resolve it, draw a perpendicular line to the horizon, to the reference, going down. So this object preventing it from sliding. In order to walk here to here, then we're going down and then going there, up, right now. So here, therefore, I will have your f cos 30. Right? So this f cos 30 are supposed to be the same, at least the same as, must be the same, yeah? Must be the same as with this one, right? Here is mg sine 30. This is an mg cos, this is vertical, this is horizontal. So going down must be the same as going up. Okay. Well, this is not up to scale because, well, this is so long, this is so short, yeah. But the concept is there. So therefore, your f cos 30 supposed to same as with mg is 8 sine 30. Okay, why is it 8? Because mass mg was given 8 Newton. You solve it based on what I have taught you in my previous video. It's cos 30 and sine 30. Therefore, calculator 4.6 Newton is what you will get. Right? I think this is basically how question will come out. But of course, there are questions that we acceleration. Yeah, this is what you need. This is what you need. Pause this video, have a look at it, understand it. Ask your friend, ask your teacher at school, if you really don't get it, all you need to do is copy this one here and this one here. Which term you doesn't understand, you just refer, ask them, what does it mean by this? I'm sure they can understand. Don't mind if you want to copy this diagram in your notebook, and then it comes with the case 1 and case 2. I'm sure they will be able to explain over to you, because I will not be there with you, but I'm sure your teachers, your school, your friends is available. Okay, that's all for me for this video. Thank you.